Okay, we're in Project F, and this is Math 122, and we're doing Sage. So the claim over here is they give you what's known as a standard normal curve, and this is the curve right over here, with the understanding that the mean is 0 and the standard deviation is 1. All right? So what they kind of ask you to do is, and this integration, I would say for the most part, when you take statistics, they have you look these integrals up in a numerical table, which is kind of old-fashioned, but it's kind of historically what's been done. But calculus can do these integrations, and so can Sage, by the way. People are often shocked to learn that it can do it. All right, but here's the deal over here. I want to claim to you over here is that kind of looking through the code just to read through. I don't know if I type it in for you, but resetting, defining the variable, defining the function. What function are we talking about? This is the function over here, plotting it out, blah, 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 and getting a picture of it, all right? So what you notice a picture of that thing, it's going to be a bell-shaped curve like this over here. It's a partial graph of f of x, by the way, just a bell-shaped curve, all right? Normal function, bell-shaped curve, all right? So then they ask you, to compute the area of it. And this is kind of interesting over here, and you might say, I wonder how Sage could do that. It's remarkable. It can do things that might be very difficult to integrate by hand, but it's able to do these things, all right? And again, it's an improper integral, but it's easy to do that, all right? Now, it depends on your ability to do prior code. That is reset, defining the variable, defining a function, and then you can iterate between minus infinity to infinity, all right? What does it give you? The number 1, which means 100%. It covers the whole population. All right, so going through the code, again, I shade it for you. Let's, 0 to infinity. Well, if it's symmetric and minus infinity to infinity is 1, you'd expect this would give you 1/2, and it does. And again, it does a remarkable job in integrating it. Remarkable. It really does a remarkable job in integrating it. This over here is the left-hand side of it, again, symmetric. Again, you'd expect to see 1/2, all right? So, 1 standard deviation. And again, these are things you learn in statistics. 1 standard deviation, and that means between, -1 and 1, that would give you an area of approximately about 68%. Again, it does the computation, and it gives you an approximate answer. You notice when I did this over here, integrate, it gives me something back that you may not understand, and that's why I did numerical approximation, and I get this over here, which roughly reads as 68%, all right? Roughly reads, so in other words, in this normal population, with a mean of 0 and a standard deviation of 1, 68% of the population are within plus or minus 1 unit of the mean, which is 0. All right? So again, over and over again, 2 standard deviations, about 95% of the population. If you want, I don't know if they did 3. Yeah, they did. You're looking at almost 100% of the population within 3 standard deviations, yada, yada, yada. All right, and that's about it. So I'm not going to type the code in for you, but I'm using 2 different types of things, integrate, and I'm also using numerical approximation to do the problems, all right? If you're wondering where these graphs are coming, I'm actually not using Sage to do these. I find it easier to use Grapher. I really find it much easier, all right? For example, let me go through that real quick, and I'll go back to the original problem, and I'll open up Grapher for you. Let me do that, and say, okay. And I'm going to get back to the original function. And what is that going to be? That's going to be y equals e to the power. And what's the power? Minus x squared divided by 2. And this whole thing is divided by the square root, sqrt, of 2 pi, 2 star pi. And I get this bell-shaped curve. By the way, someone looking at it say, I don't see the bell-shaped curve. So what I want to do is I want to, first of all, I want to clear up some of the formatting issues. And I'm going to do this right now. I'm going to get rid of the grid and the frame. And I'm going to zoom in. And what I'm going to do, I'm going to zoom out again. I'm going to use my this over here to do it, all right? I'm going to resend to the origin. And what I'm going to do over here, I'm going to select this thing. And what I'm going to do is, Grapher is a really nice application. And I'm going to do something over here. And what do I want to do? I guess I want to integrate, all right? And I want to integrate between -1 and 1. All right, and calculate. What do I get? 68.27. All right, I hope you're seeing that. It's really easy to do that. Gives you a nice little shaded thing over here. And again, if you want to, I mean, you can zoom into this better to make it look better for you. Whatever you want to do. It's easy to manipulate. It really is. You can change the numbers, the axes. You can put comments in here and all kinds of neat things you do it. Now, some things you do with that Sage, of course you can. Just Sage is a little bit more difficult to use. And so it's nice to have some different tools to use. It really is. All right, different tools. All right. So I'm going to call it quits on that. Again, the expectation is you study the material, and that does take time and effort, by the way.